This is a continuation on our video of solving by complete the square. So if you haven't watched part one, you should probably watch part one on how to solve by complete the square, because that's where I really write out all the steps. In this video, we're just doing a few more examples, just kind of reinforcing the process. So remember, you're solving by complete the square if I ask you to in directions, or if you might not be able to solve by factoring. So we use it for quadratic equations. In this case, 3x squared plus 6x minus 4 equals 0. If you are asked to solve by complete the square, you should do it that way. If not, you could try to factor it, which, you can kind of see this one wouldn't factor nicely. Thinking about things that would multiply, if you're using the AC method, 3 times negative 4 multiply to a negative 12, but also add the 6. So there wouldn't be numbers that do that. So solve by complete the square gives us another method to solve. The first thing you want to do when you solve by complete the square, remember, is make sure that your leading coefficient on your quadratic is 1. So here, I have a 3 in front, so I have to get rid of that 3. What I do is I divide by 3. Now remember, if you divide by it there to cancel to get to 1, you have to do it to every single term, including the 0. So we divide by 3 to every term, and I'm left with x squared, because the 3's cancel to a 1, that's why I did it, plus 6 divided by 3, which is 2. So we got 2x minus 4/3. If it's a fraction, keep it as a fraction. Right, equals 0. And then remember what you want to do. You want to get the constant to the other side. So I want to move the negative 4/3. That's the constant term. It doesn't have a variable with it. Don't let it throw you off that it's a fraction. So we add 4/3 each side. And I'm left with x squared plus 2x. So I kept the variables on this side. Now remember, when I complete the square, I'm going to be adding something on each side. So I'm going to put a blank there. And it's equal to, on this side, 0 plus 4/3. So I have 4/3 plus, and we're going to have a blank there. So we're adding something to each side. Now, this is where you complete the square. What are you adding to each side? Well, you're adding half of the middle coefficient squared. So 1/2 of the middle coefficient, which is 2. And then we're squaring it, right? So that's what you're really doing there. And now when you do this, what's 1/2 of 2? Well, 1/2 of 2 would give you 1. So this would be 1 squared, right? 2 times a half is 2 times 1 divided by 2. So it's 1 squared. And 1 squared just equals 1. So in this case, I'm just adding 1 to each side. So I'm going to add 1 here, and I'm adding 1 here. Now remember why we do this. We do this because the left side, right, this left side here, x squared plus 2x plus 1 now, should have become a perfect square trinomial when I just found this. So that makes it so that I can factor this down to something times itself. Now remember, the shortcut we said is, you're always going to have whatever the variable is, in this case x. This is plus, so this will stay plus, and it's whatever half of the middle coefficient was. So half of 2, remember we found is 1, so we're just going to add 1 there, and it's that quantity squared. Now, if you wanted to, you could factor this down, but some factor nicer than others. So we have x plus 1, the quantity squared, is equal to, on the right side, you just want to add these together. Now, 4/3 plus 1, you need a common denominator. So we have 4/3 plus 1 is equal to how many thirds? Well, remember, this is like 1 over 1. So 1 over 1, 1 times what gave you 3 in the denominator, 1 times 3 gets you there. So 1 times 3 gives you 3 in the numerator. So you're adding 3/3. So what we really have here is x plus 1 squared is equal to 4/3 plus 3/3, which is 7/3. Now remember, you're not done here. The idea was that we force a perfect square on the left side so we can solve by square root property. So now I'm going to take the square root of each side to get to the inside of this factor. So I take the square root here. When you write the square root, you write plus or minus in front. So the square root of x plus 1 squared is just x plus 1. Right? That's why we did it. That's what square root property tells us. It's equal to plus or minus. Now remember, if you have division or multiplication inside of a root, you can take the root of the numerator and denominator specifically here, square root of 7 over the square root of 3, individually. And if it simplifies, you should simplify it. Now, 7 is not a perfect square. It doesn't have any perfect square factors other than 1. 3 is not a perfect square, and it doesn't have any perfect square factors other than 1. So you can't simplify it in terms of that, but we want to rationalize this at least, meaning you don't want to keep the square root in the denominator. So don't forget our rules about roots. If you have a square root in the denominator, to get rid of the square root of 3, what am I going to do? Well, I'm going to multiply by square root of 3 to both the numerator and denominator. So we end up with x plus 1 equals, and this is called rationalizing, remember, plus or minus the square root of 7 times the square root of 3 is the square root of 21. The square root of 3 times square root of 3 in the denominator, the square root of anything times itself is just whatever the argument was on the inside, that radicand. But it's just 3. Square root of 3 times square root of 3 is square root of 9. The square root of 9 is 3 is another way to think of it. But remember, square root of something times itself just gives you the inside. And now we're ready to solve this. Square root of 21, again, doesn't have any perfect square factors other than 1. So I subtract 1 from each side. I end up with x equals negative 1. Make sure you have the negative with the 1. Plus or minus the square root of 21 over 3. Now make sure only the square root of 21 is over 3, not the negative 1. And, you know, these don't combine. They're not like terms. So this is two answers. This is a solution. So you have this, the two answers, right, are negative 1 minus the square root of 21 over 3, and negative 1 plus the square root of 21 over 3. Remember that over 3 is just under the 21, not, or under the square root of 21, it's not under the negative 1. And so that would be your solution. Two answers that make this original equation true, keeping in mind that this wouldn't have factored nicely. And you can tell that because if it was going to factor nicely, you would have gotten integer solutions down here, which we didn't. Let's take a look at another one here. And if you haven't already done so, you might want to pause this before we do it and try it on your own. So this one here, if I said to solve by complete the square, and we had 3x squared plus 2x minus 6 equals 0. So you might want to pause it, try it on your own, and then come back and go through it. So first thing here, we need a leading coefficient of 1. I don't have it, so in order to make this look like a 1, remember I divide by whatever that coefficient is, right? Because 3 divided by 3 would give me a 1. So we divide each term by 3, right, including the 0. This keeps it balanced. So the 3's cancel, end up with x squared plus, this is going to be 2/3 times x minus 6 over 3, well that reduces to 2, equals 0. And then remember you want your constant to move to the right side, keep the things with their variables on the left, so I'm going to add 2 to each side. So I end up with x squared plus 2/3 x plus, remember we're going to add something each side, so I'm going to put a blank here, is equal to 0 plus 2 is just 2, plus I'm going to put a blank here. Alright, and now we're ready to complete the square. Remember how you complete the square. You want to take 1/2 of what? The middle coefficient, so 1/2 of 2/3, and we're going to square that, right? That's what we're trying to find, that we're going to add to both sides. So what's 1/2 of 2/3? Now I would write this out like I'm writing it here so you can see the values. Well, 1/2 of 2/3, really what happens is these 2's cancel out, right? This 2 and 2 will cancel, so you really got 1/3 squared, and then I would square it. So 1/3 squared, remember 1 times 1 is 1, don't put a 2 there, sometimes you'll make that mistake, right? 1 squared is just 1, 3 squared is 9, so it's really ends up being 1/9. So I'm going to add 1/9 to each side. So if I add 1/9 here, and I add 1/9 here. Alright, so I'm adding 1/9 to each side, and that keeps it balanced. That's why I have to do it to both sides. Make sure you do it to both sides. And then you have to ask yourself, okay, you know, how does this factor down to a perfect square? Now, remember, this is a perfect square trinomial, so we know that this factors to, you know, x and then plus or minus whatever the middle was. In this case, it's plus, because we know it's plus, and then whatever half of the middle coefficient is what's going to use, we're going to use as our number. So 1/2 of 2/3, which was 1/3, is what we're going to really add here. So plus 1/3. That quantity squared, make sure the squared on the outside of that, right? So it's x plus 1/3, the quantity squared, equals, On this side, we got 2 plus 1/9. We want to rewrite 2 as something over 9. Remember, it's 2 over 1. 1 times 9 gives you 9, so 2 times 9 gives you 18/9 plus 1/9, because you need a common denominator when you add. And so we have x plus 1/3, the quantity squared. Right? Remember, you can just grab that right away from that half of the middle coefficient. Right? And that quantity squared is equal to 18/9 plus 1/9 gives us 19/9. So once you're here, now that you've reached this point, you should be able to solve this by the square root property. That's the idea behind this, is that you can take the square root of each side so you can get to the x that's on the inside of this factor. Take the square root of this side, make sure you put plus or minus when you write a square root. We end up with x plus 1/3 equals plus or minus. Remember how this works. The square root of the numerator, 19, over the square root of the denominator, which is the square root of 9. So this gives us x plus 1/3 equals plus or minus. The square root of 19 doesn't have any perfect square factors other than 1, and it's not a square itself. So the square root of 19 over the square root of 9, though, well, that's 3. If you can evaluate it, make sure you evaluate it. Right? Don't try to rationalize before you evaluate it, because sometimes it's easier just to evaluate the perfect square. Once you're at this point, and you want to isolate x, so we subtract 1/3 from each side. So we end up with x equals, this is negative 1/3, don't lose that negative sign, plus or minus the square root of 19 over 3. Now, these aren't like terms. When I say they're not like terms, well, I guess I should say they are like terms in terms of they don't have the same variable piece. They're not like radicals, so you can't combine them. But what you can do is, since they have a common denominator, you could add them as a single fraction, and you could write this as x equals negative 1 plus or minus the square root of 19 all over that denominator of 3. Right? And remember, this is two answers. Right? Negative 1 plus the square root of 19 all over 3, and negative 1 minus the square root of 19 all over 3. And remember, you can add these together because they already have a common denominator, so that's why you can combine them in the numerator. But they're not like radicals, so you can't combine them any further than that. And these are the exact answers. Right, two answers that would make this original quadratic equation true. Right, those are the solutions. So you wouldn't have been able to solve this by factoring, and you can see that because your answers came out to something that involves radicals. So so far we've seen answers that have radicals in them. Some of them are imaginary or complex roots, and that's okay. Those things happen, and most of the time that's what will happen when you solve by complete the square. Let's just take a look at one now where, let's say it was something that maybe you could have factored. What would happen, just so you get an idea of what that would look like. So if I said to solve, so this example, solve by complete the square. And we have x squared plus 9x plus 8 equals 0. Now, I will tell you up front, this is something that's factorable. And if I didn't say solve by complete the square and asked you to solve this, you would try to solve it by factoring first. But in this case, I asked you to solve by complete the square, so let's go through the process. All right, and you might want to pause it, try it out on your own, and then go through and watch the example to make sure you got it correct. The first thing you're looking for, though, is the leading coefficient 1. In this case, the leading coefficient is 1, so you don't have to worry about it, right? So that you don't see a value in front of your x squared, that means there's a 1 there in front. The next thing you want to do is, isolate the constant on one side, so I want to subtract 8 away from this side, so I end up with x squared plus 9x plus, remember, we're going to add something here, so I'll put plus the blank is equal to 0 minus 8 is negative 8 plus the blank here. And now remember what you want to do. You want to take, to complete the square here, right, to figure out what you're going to add to both sides, you want to take 1/2 of the middle coefficient, so it's 1/2 of 9, and then you want to square it. And I would write it just like I'm writing it here. It's helpful to see it. So 1/2 of 9, it doesn't reduce. I'll leave it as 9 times 1 over 2, which is 9/2 over 2. You should leave it as a fraction. And then that's squared. So 9/2 squared, you square the numerator, square the denominator. 9 squared gives us 81 over 2 squared, which gives us 4. So we got 81/4. And so I'm going to add 81/4 to each side. Right, now don't skip this step. I need to see you do this. Now the next step is we want to write the left side as a perfect square factor. Remember how you find this. X stays x, so x is your variable, and then you want half of the middle coefficient. That's what you're going to add or subtract here. So it's positive, so I know I'm going to add it. Half of the middle, well, we just did that in here, right? Half of 9 is 9 over 2, so it's going to be plus 9 halves, and that's the quantity squared. Remember, the reason this works is that x plus 9 halves times x plus 9 halves will give me this when I multiply it out if I was to FOIL. This is a shortcut to factoring it, essentially. So you should show this and this. It's equal to negative 8 plus 81 over 4. Remember, you want a common denominator to add this, so I want this to be over 4. Well, negative 8 over 1 equals what over 4? Well, 1 times what gives you 4? So 1 times 4 gave me 4. So 8 times 4 multiplying the numerator makes us a negative 32. Plus 81 over 4 already has our denominator 4, so we're good there. So simplifying this, I have x plus 9 halves, quantity squared, equals negative 32 plus 81. When you add those together, you can use your calculator, you should get 49 over 4. And now we're ready to use square root property. Right, that's why I did this. The goal behind complete the square is to get a perfect square on the left side so you can use square root property to solve. Taking the square root of each side, remember you got to write plus or minus in front when you take the square root. We have x plus 9 halves equals plus or minus the square root of 49 over 4. Actually, that's perfect square in the numerator and denominator. Square root of 49 is 7. The square root of 4 in the denominator is 2, so it's really plus or minus 7 halves. And now we're ready to solve for x. So remember, now when you take the square root, there's no square root symbol anymore, right? It's gone. So now to solve for x, I'll subtract 9 halves. Subtract 9 halves from each side. I end up with x equals negative 9 halves plus or minus 7 halves. Now, this is two answers. These are like terms, and they can be combined, but you can't combine them until you combine them individually because they're two answers. So the two answers are, right, x equals negative 9 over 2 plus 7 over 2, and x equals negative 9 over 2 minus 7 over 2. They have a common denominator, right? So they're like terms. They have a common denominator, so you can add them. If they didn't have a common denominator, you have to get the common denominator first, but adding them, negative 9 plus 7 is a negative 2 over 2. Negative 2 over 2 is negative 1. Right here, negative 9 minus 7 is negative 16 over 2, which negative 16 divided by 2 is negative 8. And we got two answers, negative 1 and negative 8. These are the x values that would make this original equation true, right? That would be the solution to this original equation. Notice they came out to integer values. These come out to integer values, right, like we have here. But that really tells you that the original problem was factorable in some way. Now sometimes it's more obvious than others. If you were to factor this, you would have factored this to x plus 8 times x plus 1. And then when you solve each of those equal to 0, you would have actually gotten negative 1 and negative 8. So solving by factoring would be a better method to use in this case because it's a little faster. But you might not know that going into a problem. You might have a hard time factoring something. But or I might just say, solve by complete the square. This is me testing on you knowing the method. So even if you could factor it, if you don't use the method I'm showing here, you won't get any credit if I ask you specifically to use solve by complete the square. So hopefully these examples help with solve by complete the square. You know, it really is a process that you should understand step by step going through it. The more practice you have with it, the better you will become at it. And it does come up in other areas as you go further in math, specifically when you're talking about graphing parabolas. So you will see it again at some point.